accelerating sustainability with a little help from AI and quantum. I'm Tonya Hall, and joining me is Dr. Solomon Assefa, Vice President for Climate and Impact Science at IBM Research. Welcome, Dr. Assefa.
Thank you for having me.
Explain your role, please, if you will, at IBM Research.
So I lead a global team of researchers and engineers across many continents. And the researchers are focused on leveraging some of the latest technologies such as AI, hybrid cloud, quantum, and developing more technologies so that we can solve some of the world's pressing problems, such as climate, right? How do we mitigate climate change? How do we adapt to climate change, as well as future of health and future of work? So that is the portfolio that I'm leading.
In just the past year, your team made significant progress in creating and discovering sustainable materials using artificial intelligence and high-performance computing. Start, if you will, by explaining what you define as sustainable materials.
Okay, so maybe let me just set a little bit of context to the problem that we're trying to address. And it's relevant because just last week, the UN Intergovernmental Panel on Climate Change released a very, very interesting report, right? And there's a couple of takeaway points from the report, which is one, climate change is here, right? We see it in the extreme weather events that are happening, more frequently and that are becoming more severe, such as flooding, drought, heat waves, and so forth. Second is the fact that human activity is actually at the center of it, right? If you look at just 2020, there's been about 30 gigatons of CO2 that has been emitted into the atmosphere. And mostly it's because of a lot of industrial activities, right? And so it's a pressing problem, which means that we really need to come together and focus on the problem and solve it. And fortunately, this is where technology comes in, right? Technologies that I mentioned, like AI and quantum and cloud, could actually help you accelerate in terms of discoveries and coming up with the solutions, right? So now, if you look at it from that context, it's going to be important for us to create some new materials that will be important for carbon capture and sequestration. There's a couple of ways of doing this. One could be through direct air capture. Another could be capturing the CO2 at the point source of emission. And then, of course, there's nature-based kind of approaches as well, such as planting trees, right? But it's going to be important for us to harness these technologies to discover sustainable materials that, one, allow us to do the mitigation, but also if we use these materials, they're not going to do further damage to the environment in the future. And these materials are broad. For example, like I mentioned, it could be in carbon capture, could be related to fertilizers, it could be related to batteries, antimicrobials, and so forth.
I want to talk a bit about that. In fact, most people probably identify with batteries as a product that offers a lot of opportunity for sustainability improvement. Talk more about your work there.
Yeah, absolutely. Now, I mean, you can look at that problem in the context of renewable energies, right? So that's one of the strategies that is on the table when it comes to mitigating climate change, right? So if you look at it from that context, we're looking into wind, we're looking into solar energy and so forth. All of that means that we need to develop new type of storage technologies, new type of batteries. It could be small batteries that we could use for our laptops, but also large scale batteries that are going to be important so that we save the intermittent energy and we could use it, to provide or send energy back into the grid, right? So when you look into the systems, it's going to be more and more important to discover new materials that are going to have more power density or also be more sustainable for the environment.
How does artificial intelligence contribute as a tool for creating advanced batteries?
So, very good question there. And there's a couple of steps in terms of how we can accelerate the discovery loop, right? So, obviously all of these discoveries are based on the scientific method, which has been useful for us for a long time, right? But with AI, in the first place, we could actually mine the massive amount of data and scientific knowledge that exists and use it to form very interesting and very useful knowledge graphs, right? So once you have that, then you can think about using what's called generative models to build new models that allow you to think about what new materials with new properties you could create, right? And then once you have those set of materials, you can go to the next phase and say, okay, how do I use AI to even enhance simulations, physics-based simulations, so that you could make it more efficient, more time, intensive, and less time intensive, and so forth, right? And then, of course, finally, you could use AI to automate your own lab, right? So the labs where you actually go and test these materials, the physical property of these materials, where you synthesize these materials, could be automated using AI, which means that more or less the lab could function for 24/7 without interruption, going and iterating through these materials, right? So this way, AI is going to be very useful in terms of the discovery process. But of course, beyond the material space, AI is also going to be important when it comes to carbon reduction itself, right? For example, across supply chains, as well as in terms of climate risk, understanding climate risk and impact as well.
Quantum computing plays a role, and IBM is a leader in this field. So how do you employ quantum into your work?
Well, the interesting thing about quantum is really, it's based on nature, right? It's about this, it's based on physics itself, and that's how nature operates, right? So these materials that we are trying to discover ultimately are, there's a lot of quantum mechanics, they're quantum mechanical. They're based on nature as well. So that makes it extremely useful for us in discovering these materials. So in 2022, we are planning to come up with a chip that will have over 1,000 qubits, on the chip, right? So quantum technologies are really developing fast, and over time, the coming decade, they're going to be extremely important part of our toolkit in terms of how we do discoveries.
Well, where can we go to follow your team's work?
You could go to research.ibm.com. So there's quite a lot of materials focused on climate, impact science, as well as the technologies that we discussed. And of course, people can follow us on Twitter as well.
I love it. Dr. Solomon Assefa, Vice President for Climate and Impact Science at IBM Research. You mentioned Twitter. I didn't hear any mention of TikTok, but how could we follow you guys on Twitter? You personally, maybe your team?
It's solo-Assefa. That's, and then IBM Research.
Perfect. Thanks again for joining us, Solomon.
Thank you.
And find and subscribe to more of my interviews right here on all the major podcast platforms under the Tonya Hall Innovation Show and at tonyahall.net. Thanks for watching.